Welcome all to the next topic of gravitation, and this basically will discuss about gravitational self-energy of a hollow sphere. So in the previous class we just discussed what do you mean by this gravitational self-energy. Then we'll discuss how to find out the value of gravitational self-energy of a hollow sphere. Assume that we are having a hollow sphere over here, and let's say its mass is equal to m, and Rm is to find out its gravitational self energy. So let's say its radius is also equal to r. So we discussed that the meaning of gravitational self energy is, we'll assume that this is made up of infinite number of small particles, each of mass, let's say take it as something but dm, very small part of m, and we are believing that initially all these dm parts were at infinity, and we are taking this dm part from infinity, and while putting all these dm masses over here, we are making a sphere something like this, or a hollow sphere something like this. So how much amount of work that we are doing for this process is stored in the form of energy, and that we call it as something but the self energy of system. Or we can just say in the reverse order that if you construct a hollow sphere of mass m and radius r, then how much amount of energy we need to spend to like basically divide this one into infinite number of small parts and separate all these parts to infinity. So that work done is known as the self energy. So let's see how we'll calculate it. So over here we are assuming that basically we are having a sphere over here, and while taking masses from infinity, we are putting masses from infinity, we are increasing its mass from 0 to, initially assume that mass was 0, we are increasing its mass from 0 to m, and we need to find out the value of work done for this process. So consider that at an intermediate state, its mass becomes equal to nothing but small letter m. Now we can find out if you want to add an additional mass dm over here, so how much amount of like work we need to perform for this purpose. So we know that the value of this work done to take a small mass dm, let's say that is equal to dw, and we know that work done is equal to nothing but its change in its potential energy, and potential energy we can take it as nothing but we are writing work done is basically change in potential energy, and potential energy is nothing but mass into potential difference. So we know the potential for a hollow sphere of mass m and radius r. So we can use this value over here. Its potential is minus gm divided by r. That means to put another mass, small mass dm over here, we need to perform a work done that is equal to minus of dgm divided by r into dm. Now, if you are writing, we can just modify this equation as gm dm divided by r. So if you want to find out the value of total work done to change its mass from 0 to m, so we can put a integration symbol over here, that is integration of gm dm divided by r, and we are integrating it from 0 to total mass, let's say that is equal to m. So g is a constant and r is a constant. Integration of m, we can take it as limit m square divided by 2, and the limit is changing from 0 to m, so we can write the gravitational self energy of a hollow sphere is equal to minus of g into m square divided by 2r. Hope so that you understood whatever things we discussed in this class. If you are having any doubt, please contact. Thank you.